Welcome to Industrial Problem Solving. My name is Dave Roysum. I am super excited to continue this mini-series on troubleshooting using a form of pattern recognition. In this clip, we will discuss one of the most common patterns, that is, where defects favor either the edges or the center of the web. Please see the previous clips in this series as well as the traceability mini-series if you have not already done so. I know your time is precious, so let's get started. A smile is defined here as when the waste, delay, or customer complaint histogram profile favors both edges. As we saw in Web40123c and E, 80% of your troubles may come from the outer 20% of the edges of your web. However, this definition may be complicated by the fact that sometimes problems in the center of the web, especially if they are broad and wide, may actually be a smile in disguise. We will get to that complication shortly. Just as in the last clip, an important part of this definition is the word favors. You may see the defect a bit more on the front than the back, or vice versa. You may see the defect elsewhere across the width. Still, in this case, the defect is most common on the two edges and noticeably less common elsewhere. Let us begin with a very familiar example of a smile-shaped defect histogram. Baggy edges, plural. Here we begin with an example of thick edges at the former. In this case, a cast film extruder. The physics of surface energy all but guarantee edge necking on this web former. However, this principle could apply to any root cause for any raw material if edges are different than the center. Another totally different example would be salvage edges on textiles. Different root cause, different raw material, same shape, and, as we will see, same resulting problem. Thick edges from the former must wind to a concave roll diameter profile. This is all but guaranteed by physics to happen on any winder, any make, any model, any design, and with any TNT setting. Now we add a concept introduced in the last clip, that is, of thresholding. Only the edges of the wound roll, coupled with winding tightness, are strained enough to stretch the raw material beyond its yield. So care must be taken here. The width of the root cause will be as wide or wider than where you see the problem. The result of all of this will be baggy edges. However, you will not see bagginess in the web going in or the wound roll itself. Only your customer will see baggy edges when the roll is unwound. So, what is in common with each of the four steps in this mechanics progression? Simple. It is smile-shaped profile, smile-shaped necking, smile-shaped thickness, smile-shaped wound roll diameter, and finally, smile-shaped baggy edges. Let us continue with a quite common smile shape that is not as well known. That is a chevron. Those 5,000 of you who have taken my award-winning and trademarked Web101 class will immediately recognize this example. That is the mechanics of how and why baggy edges make chevron-shaped wrinkles when they go through a nip. Those of you who do not know this really should go to school. In any case, the chevron is really a smile-shaped natural length profile. but you don't see the entire shape due to thresholding. You only see the edges. We also covered that in our class that while chevron-shaped wrinkle patterns are smiles in disguise, we cannot know whether they are caused by baggy edges or a nip that is heavy on the edges, such as due to excessive deflection or due to insufficient nip roller crowning or some other cause. The reason is that baggy edges, deflection, and crowning are all smile-shaped. We must know more about the physics or do a different measurement to tell the difference between these distinctly different root cause mechanics. Another example of a smile in disguise are fan shapes. In the figure on the left, we might plot fiber angle of a paper machine or skew angle of cast film extruders. In both cases, we are looking at the angle of the principal or stiffest axis of the material. To see the smile shape in disguise, all you need to do is to plot the absolute angle of the principal axis of the material as we covered in our Web 101 class. You will also recognize from our Web 101 class the rivers and lakes pattern that can sometimes happen if the nip profile is either smile or frown shape because either the rollers deflect excessively or the crowning does not match the deflection. Let us give another very common smile shape in disguise. That is the frown. From an earlier slide, you will recognize the quite common progression of baggy edge making mechanics. Smile-shaped thickness makes smile-shaped length that makes smile-shaped complaint histogram that favors the edges. All we add here is that the tension profile is frown-shaped. There are zillions of other examples of frown-smile pairing in the web world. Thus, the troubleshooter must be adept at considering smiles and frowns to possibly be the same, at least at the start. Yes, smiles and frowns are very similar, being mirror images. Yes, they may be both present in the same mechanics as we saw in the last slide. However, they are not always opposite sides of the same coin. For example, you can, maybe, possibly, perhaps, spread a baggy center by grabbing edges, but you can't spread baggy edges because there's nothing to grab a hold of. You can find more about this topic in my baggy web series, specifically Web 40123a and b. Better yet, you can attend my award-winning and trademarked Web 101 school that has been taken by 5,000 students just like you. There we do a deep dive on the what, when, where, why, and hows of must-know topics such as spreading, wrinkling, and much more. Smiles are nothing to smile about. They are one of the most complicated shapes to troubleshoot by process of elimination. That is because smiles and frowns are ever present and ubiquitous as seen in this very abbreviated list. In fact, these shapes are often guaranteed by the laws of physics. Perhaps the most challenging example is paper machines, which may have more than 100 components that touch the web. Every single one of those components has a smile or frown shape. If that doesn't make troubleshooting challenging enough, one of our favorite tools that we covered in the last clip, the flip tool, won't work with smiles and frowns. If you flip a frown, you get a frown. Thank you so very much for joining me in this problem solving and problem preventing series based on web profile. Stay tuned for the next clip when we will talk about another very common but perhaps in some ways easier shape, streaky webs. Here we will show how to troubleshoot ridges, valleys, lanes, streaks and stripes, and much more. If you found anything interesting or useful here, please like and share. Also, please consider supporting the work of this channel using the Patreon link below. Patreons are given special thank you gifts ranging from email help to a signed copy of my latest book, the must-have 500-page Web Handling Handbook. See you next time.